Okay, so we're going to cover section 3 of chapter 2 today. Today we're going to learn a bunch of postulates. So we're going to be able to memorize these, and we'll use the postulates and the diagrams. So here are the first 4 of the 7 postulates you're going to need to memorize. Again, we're not memorizing the numbers. You're either going to memorize the name or what the postulate states. Now remember, a postulate is going to be determined from a definition or a rule. And we've already seen all of these back in chapter 1. So the first one, the 2-point postulate, states that through any 2 points, there is exactly one line. So if I draw 2 points here, I can draw exactly one line. And this is the 2-point postulate. The next one is called the line-point postulate. And this one states that a line contains at least 2 points. So it needs a minimum of 2. And we learned this in chapter 1. When we named a line, we had to always name it with 2 points. So again, at least. You can have more than 2 points on a line, but all you need is at least 2 points to name a line. And that's the line-point postulate. The line intersection postulate states that if 2 lines intersect, then their intersection is exactly 1 point. So again, if I draw 2 lines here, so if I have 2 lines, then their intersection is exactly 1 point. Then the 3-point postulate states that through any 3 non-collinear points, there is exactly 1 plane. So if I put 3 non-collinear points here, there will be exactly 1 plane. And this one's called the 3-point postulate. The next one is called the plane point postulate. And what this one states is a plane contains at least 3 non-collinear points. Okay, it could be more, but it needs at least 3. So 3 or more. Then the next one, the plane line postulate, states that if 2 points are in a plane, then the line that contains them is in that plane. So if I draw a picture of a plane, or first I'm going to do the 2 points. So if you have 2 points that are in a plane, then the line that contains them is also in that plane. And then the last one, the plane intersection postulate, states that if 2 planes intersect, then their intersection is a line. And back in chapter 1, I showed you that with 2 pieces of paper and how I put them together. So let me go ahead and try to give you a visual here. So if I draw 2 planes, then I can draw the line of intersection right through here. So this would be 2 planes. I have a blue one and a red one, and when 2 planes intersect, their intersection is a line, and that's called the plane intersection postulate. And again, you're going to need to memorize all of these postulates for the quiz and the test. So a line is perpendicular to a plane if and only if, oh, look at here, we got a biconditional. A line is perpendicular to a plane if and only if the line intersects the plane in a point and is perpendicular to every line in the plane that intersects it at that point. Now, the symbol for perpendicular is an upside down T. When you see it in a diagram, you're always going to look for a right angle symbol. So notice here is my line T that is going through the plane. And notice that when it intersects, there are right angle marks indicating here. Without those right angles, you can't assume that that line is perpendicular. But because both line P and line Q have the right angle markings there, we can tell that that line T is perpendicular. Now, you're going to get pictures similar to these on your test and quiz, where I'm going to give you this diagram and you have to name the postulate that is illustrated. So here, now if you forget the name, you can always describe what's happening. So in this picture, it's showing me that if two lines, and that's what's pictured here, and they're intersecting. So if two lines intersect, then, and notice what's highlighted in red, their intersection is exactly 1 point. Now, that's just describing. If you prefer to tell me the name of this postulate is the line intersection postulate. So on the quiz, you can either, if you forget the name, describe what you see in the picture. The second picture, yes. Right, so for the next one, notice in the picture I have two planes. So if two planes intersect, then their intersection is a line, and that what was highlighted in red. This is called the plane intersection postulate. This is the name, or you can describe what you see. It says, use the diagram to write examples of the plane line postulate and plane point. So let me do plane point first. Now, when it asks you to use the diagram, then you're not just going to restate the postulate. You have to give me specific points or lines or whatever it is from the picture. So remember, the plane point postulate states that a plane contains at least 3 non-collinear points. So now I'm going to say specific to this picture. Now, Q is the name of the plane and so is P. But I'm going to use plane P, and my statement will be plane P contains at least 3 non-collinear points A, B, and C. So I need the specific plane that's in the picture and then the 3 non-collinear points. For the plane line postulate, This one states that if a plane contains 2 points, then the line containing those 2 points is also in the plane. So let's go ahead and do specific to the picture. So I can say that points A and B lie in plane P. So line, and you can either say line N, or you could also call it line AB, containing points A and B. I'm going to switch colors here. Also lies in plane P. So if 2 points are in a plane, then the line that contains those points is also in the plane. 2 more examples and we're done. Yes?
Those are 2 examples of what you could write.
I'm sorry?
Those are 2 examples of what you could write.
Correct. Yep. See, line M doesn't have 2 points on it, so that's why I used the one with points A and B. All right, let's keep going. Next one says, which of the following statements cannot be assumed from the diagram? So for this one, it says, the first statement, A, B, and F are collinear. Well, A, B, and F are right here. Yes, they are all on the same line. So yes, this one can be assumed. The next one though, E, B, and D, well, E, B, and D are here. I can't draw in the line myself, so this one is no. You cannot assume that they're collinear without the line being drawn in the picture. The next one, line AB is perpendicular. Remember that upside down T is the perpendicular symbol to plane S. Well, AB is right here, and yes, it is perpendicular. It's got the right angle here, so this one is yes. However, CD over here, there is no right angle marking here, so this one is no. And then the last one, line AF intersects BC at point B. Well, here is AF, here is BC, and we can see that their intersection is point B, so that one is yes. So the vertical angles, because there's fewer, I have vertical PWV along with TWQ is a pair of vertical. Remember, you can also reverse the order of the letters. So I could have also said it as QWT. And then I have another pair of vertical over here. And I can say angle PWT along with angle VWQ. These are the vertical angles. Now, there are a lot of supplementary pairs here. So I have a supplementary pair here with PWV along with VWQ. Notice it forms a straight line. There's supplements. So for the supplementary, again, we can call it PWV along with VWQ. Now, in addition to PWV, you could also do PWT. So PWT can also go with PWV. Then we could also do TWQ with PWT. So TWQ and PWT are also supplements. So there's a whole bunch here. You can keep going around. I could also go here, the TWQ with this one over here. So TWQ can also go with VWQ. So again, this picture has lots of supplementary, and again, you can reverse the order of the letters, but notice on all of these, W was the middle letter. So that is it for section 3.